let's simplify this circuit down to its Thevenin equivalent. Thevenin's theorem states that for any linear two-terminal circuit, we can represent that circuit with a voltage source in series with a resistor. We can call the voltage source VTH for V Thevenin and the resistor RTH. You may have heard of Norton's theorem. Norton's theorem is basically the same thing, except you simplify the circuit down to a current source in parallel with the same resistor. So how would we do it for this circuit? Well, the first step would be to find the equivalent resistance from the terminals, from these two terminals, we'll call them A and B, RL being the load resistor. And we do that by killing off the source. Since it's a voltage source, we're going to short it. So this circuit becomes this one right here. Like that. This being R1, R2, and R3. And now we can see that the equivalent resistance would be these two resistors in parallel and then in series with this one here. So we can say that REQ is equal to R1 parallel with R2, and that adds in series to R3. All right, we have pretty much found the equivalent Thevenin resistance, which is this value right here. Now we need to find the Thevenin voltage. We do this by opening the load. Draw this out. We do this by opening the load, just like we did in the first circuit when we found the equivalent resistance. And now we have to find this open circuit voltage. And this will be the same as the V Thevenin voltage right here. So we can do that with simple voltage division. We can see that VOC is equal to R2 over R1 plus R2 times the input voltage, which is, we can call it Vs. I should have labeled it up here. Vs. It's just a simple voltage division formula. You might be wondering what happened to R3. Well, if we're measuring the voltage from these terminals, R3 doesn't make a difference because no current would ever flow through because it's an open circuit here. So you could effectively remove R3. And this would be our open circuit voltage, and that would be the V Thevenin voltage. And for Norton, once you have the Thevenin equivalent circuit, Norton is pretty much a source transformation of Thevenin. So if we were to turn this to Norton's version, it would be a current source and current source and a resistance. And you would find the current source with I is equal to V over R. You'll notice that RTH and RTH in both circuits are exactly the same.